Yeah.
Start charging you $1. I'd be rich. My car sitting here?
He'd only rebound like on the free throw line, and then like be facing this way, and then just jump and spin and like throw it up. That's terrible.
All right, I got most of you guys' homework in Google Classroom, but if you didn't do that, please come give me your hard copy.
Today is Friday, March 1st, 2024. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All students, please make sure to wear your IDs when you're at school and have a hall pass when you're out of the classroom. Thank you and have a great day.
Okay, no other 99s? All right, so today, as I told you guys yesterday, we would focus entirely on the separation of variable questions. So in this unit, you're actually closer to being prepared for the test than you may realize, because there's three main topics on this next unit. There is the slope fields, which you already saw everything you need to know about slope fields on that one worksheet. So of course I would recommend you review it before the test, but there's not more to slope fields that you haven't already seen. The second one was the one that we did the majority of class yesterday, the exponential growth and decay questions. Same thing, I think it would be good to review that, but there's not anything outside of that one worksheet that you need to be able to do for our class. And then the third one is the separation of variables. So this is the one that just takes a lot more practice. So today, this is the only skill we're going to worry about. And I'm going to do, I'd say, more than half of this with you or for you, and maybe slowly wing you off and try to get you to feel as comfortable as possible at the end of class. But there's a good chance, even at the end of class, you still feel like you need some more practice. On Tuesday of next week, they'll have a few other things mixed in, but the majority of Tuesday's class will also be about this skill. So the first thing we're going to do is number 100, the handout that you guys picked up. Within separation of variables, sometimes we have absolute value signs that we need to know how to deal with. So I've got a couple quick examples there for you to see how to handle that, so that when we get to those questions, that won't be new to you. Then we're going to go back and do a few more questions on 98 that we started last class. I did like 3 of them for you yesterday, just so you had seen it before. Then we'll work through this book assignment as a class, where again, I'll mix between me doing it for you versus you trying some of it. And then hopefully by the end of that, you'll start to feel like you have a decent grasp on this skill. But again, you'll probably still feel like you want more practice. Okay, so looking at $100. Zoe, I need you to put that up, please. Okay, so I've got 2 questions on the bottom of this that are halfway solved, and then both of these questions have absolute value signs. And in mathematics, we can't really just pretend like those absolute value signs are not there. We have to know how to accurately and consistently be able to deal with those. We can't just ignore them. So it really comes back to this one example, and I'm going to do the same thing on these questions when it gets down to this. There's more than one answer to this. The absolute value of x could equal 2 if x was 2. So if the stuff under the absolute value sign is equal to the other side, it's true. Or if the stuff under the absolute value sign is equal to the opposite of the other side. Because if x is negative 2, the absolute value of that makes it positive 2. So for us, when we're going to use this in just a second, it could be that the stuff under the absolute value sign is equal to the other side, or not both. It could be equal to the opposite of the other side. So we will have to check. Sometimes we'll leave it alone. Sometimes we will need to multiply by a negative to make it be correct. Okay, both of these questions, I think both of these come up actually in our book assignment today, but I've already done the first couple steps so that we can kind of focus a little bit more on just this absolute value part. But you may recognize these later on today in class. So I have already separated, I have already integrated, and now we need to solve for c and then solve for y equals. So again, like I mentioned yesterday, you can actually solve for c at just about any step that you want to. Just be consistent that you plug back in for c wherever you start solving for c. I tend to just solve for c as soon as I see it. Just I don't know that that's always the best move, but it's at least consistent for me. So if I plug in 1 for y, this becomes negative 1. You can't take the log of 0 or negative 1, which is why these absolute value signs are necessary. The absolute value of negative 1 would be positive 1. And then what is the natural log of 1? Okay, and 0 times this becomes 0. Over here you plug in 2 for x. And we now know c is negative natural log of 2. Now, the reason I'm able to just ignore these absolute value signs is because I know 2 is positive. So I don't have to worry about that value being something positive. Okay, so I start solving for it here. So that's where I would plug it back in. All right, did we talk about exponentiating yesterday? That word didn't come up? Okay. So to dig out this y, we're going to have to pull out an unusual algebra trick. But before we can do that, we really want to get rid of this negative 1/2. So let's multiply everything by negative 2. So we get down to this. All right, so next thing I have to show you is an algebra trick called exponentiating. If you did pre-cal last year, I think it came up in maybe like 2 questions total. We may have just shown it to you, but if you skipped pre-cal last year, you probably have never seen this before. But there's an algebra trick that's completely legal to do, where you make the entire left side the exponent of something. I'm going to make it the exponent of e, as long as you make the right side the exponent on the same thing. So the left side has become an exponent on e, and the right side has become an exponent on e. That is what we call exponentiating. The way I know to do this is because there is a logarithm property that I know you have seen. But to be fair, when you saw this in Algebra 2 and Pre-Cal, you pretty much just needed to memorize the pattern so that you could get it right on a question or 2 on the test, but then you never had anything that you actually had to use it for. Well, you're about to see why you needed to learn that. If you have a number to the log and the base is the same number of something, all of this just simplifies to be the something. So the reason why I wanted to raise this to the power of e is now this is e to the log base e of some stuff. So because of that log property, it just becomes that stuff. That's the only way you're going to get that y out of that. Sometimes students like to think like maybe divide both sides by natural log, but this isn't natural log times this stuff. It's natural log of this stuff. They're stuck together. Okay, and then another thing it's kind of backwards from what you guys have seen, but you should know when you multiply things with the same base, you add the exponents. That's why x times x is x squared. So right here, I have something where the exponents are being added, so I'm going to go the other direction. I'm going to go this way and split that apart. That's like e to this times, it's not plus anymore, e to that. And that seems kind of weird, but we just use this quite a bit in most of our questions here. So now, the reason why we want to split them apart is I can apply the same logarithm property to make both of these look nicer. In logarithms, we often have an exponent on something we're taking the log of and we bring it down, but you can also bring it back up like that. And now each one of these is this property that I use to go from here to here. I've got e to the log base e of some stuff, so this is just going to become some stuff. I can ignore this absolute value sign because anytime you have something squared, it's going to be positive anyway. So times e to the log base e of some stuff is just going to become some stuff. And 2 squared is 4. Alright, so it didn't hurt you to see that. Again, we'd probably see that when the question comes up anyway later. But here's the real focus of why I want you to have this handout. This absolute value sign, you can just make it go away, and sometimes you're going to get lucky and sometimes you're not. You really need to, before you drop this, to make it go away, you have to remember what we talked about at the top of the page. With absolute value signs, the stuff under the absolute value sign could be equal to the other side, or it might be equal to the opposite of the other side. So how we're supposed to know is we have to use this point a second time. We will plug in 2 for x and 1 for y, and this is either going to be a true statement and I will leave it alone, or they're going to be the exact opposite of each other. One's going to be 10 and one's going to be negative 10, and that tells me it's the opposite and I need to squeeze in a negative. So if I plug in 1 for y here, this becomes negative 1 on this side, and if I plug in 2 for x on this side, I end up with positive 1. So notice these are not equal. It's supposed to go to this point and it's not going to this point. So for this question, it happened to be that the stuff under the absolute value sign was equal to the opposite of the other side. I had to squeeze in that negative so that the left and the right side are equal. You have to do that check to know whether the other side is supposed to be positive or negative. Okay, and then we could just subtract the 5, and we could divide both sides by negative 6. Solving for y was the easy part. Okay, well, let's go look at that one more time with the other example here. Again, it's going to come up in other stuff too. I just wanted you to have one handout that just focused on this. Okay, so I have already separated the variables. I've already integrated both sides. And so the first couple steps have already finished here. So now that we have the plus c, we could plug this in and solve for c. If I plug in 2 for y, this becomes negative 1. The absolute value of negative 1 is positive 1, but the natural log of 1 is 0. Times a negative is 0. Plug in 0 for x. It looks like c is 0. Again, usually c is not something too messy, The last question where it was natural log of 2 is about as messy as it would ever be. Okay, and then to solve this, again, this negative is kind of in the way before I can use this log property. So take one step and just multiply both sides by a negative. Alright, but this sounds like this might have been new to you today. This is not natural log times 1 minus y, where you can divide both sides by natural log. It's natural log of this stuff. So there's only one way to dig this y that we're trying to solve for out of this, and that's with exponentiating. Make both sides the exponent on e, because now the left side is e to the log base e of some stuff. So from that log property, it just becomes this stuff. Next, I'd like to get rid of these absolute value signs. So what we need to do is make them go away. And again, this is the point of this handout. If you just make them disappear, sometimes you're going to get lucky. It's going to be a coin toss. Sometimes it's going to be fine, sometimes it's not going to be fine. But if you can do all the rest of this, you don't want to miss the last point or two from not dealing with that correctly. So you have to use this point a second time. Plug it in and make sure that the left and the right side are the same. And if they're opposite, that's how we know to squeeze in a negative. So if I plug in 0 for x, all of this comes 0. Anything to the 0 power is 1. If I plug in 2 for y, this side becomes negative 1. So for this question, it looks like the stuff under the absolute value sign was not equal to the other side. It was equal to the opposite of the other side. Again, we know that that happens. It could be equal to the other side or equal to the opposite of the other side. So by plugging in 0, 2, I can see that it's not correct yet, but multiply this side by a negative, and now it is correct. Finish by subtracting 1 from both sides and multiplying both sides by negative 1. Now, this is optional, but fairly strongly recommended. I used this initial point to solve for c. I also used this initial point to make sure that this side was supposed to be positive or negative. In this case, it was negative. But just kind of, you guys have a sense for how long these questions are, and you know the longer a question is, the easier it is to have a careless mistake on. A good idea is at the very end, make sure your answer actually goes to this point. If your answer doesn't go to this point, then you know something's wrong. And if it does go to the point, it's probably right. It would be a weird coincidence that it went to this point and not be correct. And that may sound kind of messy, but again, if you plug in 0 for x, all of this goes to 0. Anything to the 0 power is 1, and 1 plus 1 is 2. Plugging in 0 for x and getting y for 2 was true at the end of the question. So, and just to be transparent, when we give multiple choice questions, sometimes just checking that you can eliminate a choice or two, because some of the choices wouldn't even go to the point it's supposed to go through. So, okay, so let's now file that away. So if you have questions about the absolute value as it comes up, you can look at that. And to see what will we do next. Separation of variables. So the one we looked at last class, I'd like to do just a couple more on this, and then we can slide over and spend the rest of the class on the book assignment. This is the handout from last class. We will completely finish this worksheet on Tuesday, but today we're just looking at a couple more. Alright, so I know I showed you 3 of these questions yesterday, and I've warned you that this takes a couple class periods of practice before you start to feel pretty confident. But also from those two on the other worksheet, you can kind of see that these questions can be kind of messy and take a little bit more focus here. So once again, all of the steps can vary in difficulty, but the thing that you have going for you on these questions is they have pretty consistent steps. Generally, your first step is going to be split apart the variables. So put all the R stuff on one side, put all the S stuff on the other side. Usually X's and Y's, but it can be R's and S's. The reason why you want to separate these variables is because then it's easy to integrate both sides. This is an understood 1, so integrating 1 dr would be R. Over here, we could raise the power by 1 and divide by the new power. Don't forget your plus C. And since this is dr over ds, I know that they want me to solve for R. Not every question is going to be super long, but every question will need you to separate the variables, all of one variable on one side, all the other variable on the other side. Every question will have you integrate both sides. Sometimes it's easy integration like this. Sometimes you will have to use U substitution. Not often, but occasionally. Every one of these questions you have to deal with C. Either putting plus C down or putting plus C down and then solving for C. And every question will have you solve for Y equals, or in this case, R equals. Okay, so number 4 throws, let's look at one more of these and we'll look at one more of these down here and then we'll move over to the book assignment. And of course the book assignment kind of starts off a little bit easier at first and builds up to the harder questions. So unlike the first 3 questions here, they showed you dy dx, and in this one they show you y prime. So remember, y prime is the same thing as dy dx, just different naming conventions. But for separating variables, you really want to write this as dy dx so that you can see those variables. Okay, I mentioned yesterday that it doesn't make sense for dx or dy to be in a denominator. To be useful, it's got to be up here in the numerator. So the fact that dy is in the numerator on the left tells me that the y stuff probably needs to go to the left. I can multiply both sides by dx so that he's up in the numerator. But to get this y over, I would need to divide both sides by y, and then to get this x over, I would need to divide both sides by x. That's the separating the variables. A little harder than question 3, but still not too bad. The point of separating the variables is so that we can integrate both sides. These are basically the same thing, except one's a x and one's a y. So every question you have to remember your plus C. Sometimes you need to solve for it. Sometimes just saying plus C is enough. And every question you need to solve for y equals. So how do I get this y out of this natural log? Exponentiate. So let's make this an exponent on e and make this stuff the exponent on e. Okay, so e to the log base e of some stuff is just going to become the stuff. I showed you this on the other worksheet and this seems kind of weird, but we can actually split this up. This is like e to the c times e to the natural log of the absolute value of x. Again, you guys are used to going this direction. On these questions, we often need to go in that direction. Multiplying things with the same base is when you add the exponents. I'm unmultiplying them. Now, to drop these absolute value signs, I would need to test a point, but we don't have a point in this question, so we can go ahead and just remove that. What does this become? Right, this just becomes x. E to the log base e technically absolute value of x, but normally we would just call that x. Now, this one might seem kind of weird too. You guys remember that e is a number, about 2.718 or something? Okay, so I've got a number to an unknown power. On these question types, we would just change that to an unknown number. And they're going to do that to you on multiple choice questions. I know the number e, but if I don't know what you're raising it to, this is still just an unknown number to me. So we would just call him c. That's the answer to that question. Just like if it was c times 2, we're still going to just call it c. An unknown number times 2 is still an unknown number. It's not the same unknown number, but it is an unknown number. This also goes back to this. When I removed this absolute value sign, I didn't really know if this side was positive or negative, but this c is a little bit of a buffer. If the side's supposed to be negative, c just becomes negative. If the side's supposed to be positive, then c becomes positive. So that flexibility of not knowing what c is, he could switch to be positive or negative, and that's sufficient for making those absolute value signs go away. Okay, and then let's talk about one where we actually have to solve for c. So let's look at question 9, and then we will quit with this handout for today at least. So I don't see the dy dx, so might as well make a step out of that. Okay, I've got lots of x stuff and not much y stuff. So I could add the natural log of x squared to the right. I could divide both sides by x. I could multiply both sides by dx. And I could divide both sides by 2 also, but I'm just going to leave it on the left, and I'm going to leave dy on the left. So that's the separating the variables. Only y stuff on the left, only x stuff on the right. With constants like 2, you can either leave it or move it. It's whatever you think is going to be easier. I would just say leave it most of the time. There's no point in moving it. Okay, so we need to integrate. Now that the variables are separated, the left side is going to take me about 2 seconds to integrate. But the right side is, let me put my plus c before I forget. The right side, this is not as easy for me to do. So unfortunately, this doesn't happen a lot, but when we need u substitution, we're going to have to use u substitution. So I will try to make u be, I don't know, let's try the natural log of x maybe. Yeah.
Isn't the left side just 2y and not y squared?
Yes. Sorry. Thank you. So just because the integration was quicker, don't make the mistake that I did and do it too fast. Okay, that doesn't quite work because I wouldn't have a square here. This isn't the natural log of x being squared, it's natural log x squared, just the x is being squared. So let me change u to be this. So his derivative would be 1 over x squared times the chain rule. These x's could cancel. And I need it to be a 1, not a 2. Okay, so this guy could be 1/2 u squared du. Again, if you feel like u substitution is a weakness of yours, you got to make yourself keep practicing it. Alright, so now we can integrate this side. Raise the power by 1, divide by the new power. plug in U. And I'm going to move the plus C to the right. You could put it on the left or the right, but it doesn't matter. Most people just do the right. So it doesn't look like it's going to be too hard to solve for y on this question. We're not going to have to do any weird exponentiating or anything. But what is different about this question and why I wanted to do one more here is that we do need to solve for c. So if I plug in 2 for y and 1 for x, it looks like c is 4. So I started solving for it here, so I need to plug it in here. Now I'm cheating and just erasing c and changing it to 4. Don't do that on FRQs. Just make a new line. If I don't see that you dealt with c somehow, well, I guess maybe this would be enough. But finish solving for y by dividing everything by 2.
Could you simplify it earlier?
Yeah, you could have.
Because you could bring the 2 out of the ln x squared to 2 ln x and then cancel the 2's.
You could have done that, yes. Yep. Just be careful that you're being consistent. You're not doing different order of operations or something.
Can you scroll back a little bit?
Is that enough?
Where did 1/6 come from?
It was 1 over 2, and then I integrated this by raising the power from 2 to 3, and then I had to divide by the new power.
Where did you use squared? Because I thought you set u to be ln x squared, or natural log of x squared, which is just numerator. So wouldn't that be I du? And not u squared du?
You were right. Yeah, sorry. This would just be u du. So this would be just squared. I was about to say something, so I would have caught that, but I wouldn't have seen what it was. So this would be a 4th. Let me just erase this. I guess if anything from my mistake here, you guys can see it's a pain to go back and try to redo stuff, so it's better to be careful and slow. So now if I plug in 2 for y and 1 for x, okay, I guess I was getting lucky. I guess c is still 4. I believe this to be okay. But what I was about to say, and I can check to see if there's still a mistake here because I am kind of rushing the my correction. Divide both sides by 2 to get down to y equals. And my tip for you that will help you catch some of that small arithmetic stuff is double check that it does go to this point at the end. If I plug in 1 for x, just a second. If I plug in 1 for x, all of this goes to 0, plus 4 would be 4, and it's supposed to be equal to 2. So I know that there's still a mistake there. So, Blake, did you see it?
Is it 1 over 8 now instead of 1 over 4?
Um,
On like the end, you just divide the whole right side by 2.
Okay, so yeah, when I went from here to here, I divided this by 2, and I didn't divide the other side by 2, which I have no idea why. Okay, now let's test the initial point. Sorry?
Should be an 8, not a 1/2 or 1/8. You're a 1/2.
Okay, now if we test the initial point, 1 in for x, this all goes to 0, plus 2 is supposed to equal 2. So, if nothing else from that, I guess be careful with your arithmetic. One slight mistake, you know, I have the benefit of you guys have all the eyes on it, so it's quicker to find the mistake. Of course, if you're trying to find your mistake on your own, and the question is long and messy, you know, sometimes it's almost better to just start over. But and test this point at the very end. It doesn't take but a second, and it will either make you feel good about your answer or at the very least let you know something's wrong about your answer. Okay, so now let's kind of reset here, because again, the book assignment isn't going to start off that difficult. It's going to start off a little bit slower. So we are going to be doing 1 through 23 odd, page 405. So you need a separate sheet of paper for this. Again, keep that assignment because we will finish it on Tuesday. Okay, so I don't think you guys should have any homework for this. I think we will have time to go over all of it, but I'll be honest, a lot of it has to do a little bit with how quickly you guys are moving on and respond here, because I'm going to have to start asking you guys to practice a little bit and asking you guys some questions so I get some feedback, and then I can try to help address whatever part is giving you the most issues. So, again, page 405. We're going to just do the odds 1 through 23. So it's like 10 or 11 questions. And then there's question 1. So all of these questions, the first thing you should do is separate your variables. So I want you to do just that step, and then I will finish the question with you. Again, as we go through this, I will try to ask you to do a little bit more each question and practice a little bit more. I'm not throwing you to the fire just yet, but just separate the variables. Okay, so for this, you should have multiplied both sides by dx and multiplied both sides by a y. If you did that correctly, you knew what I meant by separate the variables. Okay, now let's just finish it together and you can just copy along with me. The point of separating and how you know to remember to separate is because that is what makes the integrating of both sides work out nicely. Luckily, neither one of these needs u substitution. Most questions won't. Now, technically, when you integrate this side, you should have a plus c, and then when you integrate this side, you should have a plus c. But then you could just combine those c's. An unknown number, subtract an unknown number is just an unknown number. So we really only need one plus c. You're welcome to put them on both sides, but if you combine them, they're just a different unknown number anyway. Okay, and then what would be my last goal for this question? Solve for y. So let's multiply everything by 2. You think I should call this 2c? No, just call it c. If you really care, this doesn't matter at our level, but at some point in your math career, someone might call this like c1 and c2. This is an unknown number, this is an unknown number, they're different unknown numbers. This one's 3 times bigger than this one. So if you really care, feel free to call this c1 and then call this guy c2. Your AP exam does not expect you to keep up with that though. Okay, and then square root both sides. So I have to try to annoy you with the steps, but we separated, integrated, dealt with the plus c, and solved for y. The separating wasn't too bad, the integrating wasn't too bad, remembering c, and then solving for y wasn't too bad. But of course, each of those steps can be more difficult as we move along. Now, one other thing I want to add before we go on to question 3, I guess I'll go ahead and write it down in case you don't have a book in front of you. But even though these questions are pretty long and they can sometimes be kind of nasty, when this shows up on your AP exam, they are very fair about this. Again, we're not looking at any exact scoring of any FRQ today, But when this shows up on the AP exam, it usually doesn't show up as multiple choice. I believe that's because these questions usually take longer than 2 or 3 minutes. And on multiple choice, they give you an average of 2 to 3 minutes. So that doesn't mean that they can't give you longer questions, but then that means they need to balance it out with shorter questions. So these don't tend to show up often as multiple choice. But they do often show up as free responses. That being said, when it shows up as a free response, it's usually worth 5 or 6 points, and they are very friendly with giving you the points. Again, this is not a real one, but tend to be what they do is they tend to give you 1 point if you just separated the variables correctly. They tend to either give you 1 or 2 points for the integration correctly. Sometimes you have to integrate both sides correctly to get the point. Sometimes they give you a point for integrating the left side correctly, and then a third point for integrating the right side correctly. They tend to give you a point for remembering the plus C or solving for C if they gave you information for it. And the very last point, you actually have to get down to y equals. But the separating, the integrating, the remembering the plus C is the bulk of the points, and that's usually like less than half of the work. So it's very fair, even though these questions can be difficult at times to get to y equals. Okay, so for question 3 now, I would like you to try to separate the variables and integrate both sides. And just for time purposes here, I'm going to do it at the same time as you, but I'm going to freeze my screen. So separate and integrate, and then we will solve it together, solve the rest of it together. Remember, your dy needs to be up in the numerator, not in the denominator, and your dx has to be up in the numerator also. It doesn't make sense for those to be in the denominator. Okay. So for this one, to separate, you would have to subtract the x squared over and then multiply both sides by dx. That would get you to right here. If you separated correctly, you should be to that step. Then to integrate both sides, you should be down to this. And I highlighted the plus c. Make sure that you remembered the plus c. Again, we're not looking at FRQ scoring today, but when you see how they score these, they do penalize you quite a bit if you forget the plus c. They put a cap on how many points you can earn on the whole question if you forget the plus c. Okay, but honestly, if you can do that, you really should have been able to finish, because we're trying to get this down to y equals. So we could multiply everything by 2. We could divide everything by 5. Again, different unknown numbers, but they're still unknown numbers, and eventually square root. Or you could just multiply everything by 2/5 if you want to do it in one less step. But these questions are already going to be long, so there's no benefit in trying to make it 8 steps instead of 9 steps. Do yourself a favor and try to do not too much per step so you don't make a careless mistake like I did on our notes earlier. Okay, you guys okay with that one? Okay, then let's keep going. Question 5 sort of looks like one that we did on the notes earlier with DRDS. Since this is dr over ds, our goal in this question is going to be trying to solve for r. Now for this one, I'll ask that you go ahead and try the whole thing, just because it's a little bit smaller of a question. So take a moment and see where you get stuck or see where you end up going wrong. I'm gonna give you just one more minute. If that's not enough, I'm sorry, but at least you'll know where you slowed down. Okay, so the fact that dr is already up in the numerator is my hint that the r stuff needs to move to the left. So you had to divide both sides by r. You can do what you want with the 3/4. If you want to multiply both sides by 4/3, I guess you can, but that's not any better. So I would just leave the 3/4 alone and move the ds over. That's what I would consider separating the variables. Then when you integrated, this is one we have memorized, the natural log of the absolute value of r. This is an understood one, so integrating 1 ds would be s. Does that look good? Plus c, good. And if we're trying to solve for r, the only way to dig this r out of the natural log is with exponentiating. So see if you thought to try that. The whole point of exponentiating, and this is how you're going to know when to do this, is because e to the log base e of some stuff just becomes the stuff. Over here, I can split this guy up. This is like e to the c times e to the 3/4 s. And the reason why I want to write it like this is a number to an unknown power is really just a different unknown number. And that's kind of important because they always do that on multiple choice. So now finally, to drop the absolute value signs, this side could be the equal to R, or it could be equal to the opposite of R. But we've got this C value, and sometimes on our solutions that I didn't do, sometimes teachers will use K, where K represents positive or negative C. You don't have to do any of that, but if C was 5 and it was supposed to be -5, like, it makes no difference to our work. So we can just drop it. C would absorb the sign change if needed, and that's where you're aiming for. So I suspect most of you probably separated and integrated okay. I suspect about half of you thought to exponentiate, but this part, again, is kind of weird. This is e to this times e to that, and the reason why you need to split that up is e to the c can just be rewritten as c. They're always going to do that on multiple choice, so you need to make a habit out of that also. All right, questions you would like to ask about number 5 before number 7? Cooper, you need to put that up. Okay, then now let's kind of flip it a little bit. Let's start 7 together, and then I'll have you try the end of it, because you need to try to practice all parts of the question. But again, I know some of these are a lot before you get much practice. Okay, so 7 has a y prime, so change that to dy dx so that you can see the y and the x. Since dy is in the numerator, let's try to get all the y stuff on the left. Dx is in the denominator, so multiply both sides by dx so that he's in the numerator on the right side. I don't know. You can choose what you want to do with the 3. You can leave it or you can divide it, but this y needs to move over. So I guess I'll just divide both sides by... Actually, no. I'm going to leave the 3 over here. It's really just a preference thing. And divide both sides by 2 plus x. Now the variables have been separated. Okay, now I want you to think about what comes next and try to do that. didn't want to give you too much advice on the right side here, but I do want to kind of show you one thing that you guys might want to start doing here. Of course, you should have started to integrate both of these. This one is one we have memorized, so that should be instant. Over here, you are welcome to do U substitution. U substitution is the one that's always going to help you with chain rule so that you don't have to do chain rule in your head. But sometimes, if it's just one step of chain rule, it's a little bit quicker to do guess and check instead of chain rule. So, for example, I know I need over 2 plus x, so I know I need an absolute value of 2 plus x. Now, if I guess this, just make sure you check it. If I took the derivative of this, I would get 1 over 2 plus x. Is that what I wanted? No, I wanted it to be 3 times that much. So, well, actually on this one, I don't know if I'd even really call that chain rule. I guess I'm kind of lying. This 3 is like a constant. We could have moved it out front like this. But you could have also left it under and done U substitution if that's more convenient to you. All right, to finish, I feel like at this point you should be familiar with the exponentiating. E to the log base e of this is just this. But when you exponentiate over here, this 3 is in the way. This isn't e to the log base e of some stuff. It's e to the 3 log base e of some stuff. That's not the property. So in logarithms, if you have an exponent on something that you're taking the log of, you can bring it down. But if you prefer, or in this case what you need to do, is bring it back up. Now it's e to the log base e of some stuff. So it just becomes that. And then times an e to the c, not a plus. Multiplying things with the same base, you add the exponents. Here's where they're being added, here's where they're being multiplied. And then change e to the c to just be c. I can ignore the absolute value sign there because if the other side's supposed to be the opposite, it would just flip the sign of c, which I don't know what c is anyway. Okay, so you guys have questions about 7? Okay, so then let's keep on going, but now I need to start asking some questions so I can see where you guys are hesitating and I get an idea of what's working well for you and what's not working well for you. Okay, so question 9. How should we start this off? Okay, very good. We want to see the y and the x's, so that's a good idea. Okay, somebody else, what would be next?
Multiply by dx.
Okay, multiplying by dx correctly separates the variable. All right, somebody new, what would come after that? Okay, it's fine to integrate one side as long as you integrate the other side. Keeps your equation balanced. Okay, somebody tell me how this integrates. Okay, and then somebody else, somebody new, tell me how this integrates.
Negative cosine x.
Sounds good. Never forget your plus c. And the whole purpose of these questions is we are trying to, when you solve a differential equation, you're trying to find the original function. You're trying to solve for y equals. So we could finish by multiplying everything by 2. Unknown number times 2 is still an unknown number, and square root. You should be starting to feel fairly comfortable with what the steps need to be. Question like this I think would be pretty fair for where you guys are at, because the separating wasn't too hard, the integrating wasn't too hard, the solving for y wasn't too hard. But you guys know that that's going to change. Some questions are going to have some parts harder than others. So, All right, anything you guys would like to ask about on number 9 before I move on? Okay, so let's try to keep it up here. Again, I'm not trying to rush, but I also don't want to leave you with more homework than is necessary. All right, so how can we start this one? Okay, just like last question. All right, somebody different. Tell me what else we need to do after that.
Multiply dx.
Okay, we could multiply dx over. Anything else?
Divide by square root of 1 minus 1 squared.
Okay. Okay, the next thing is going to be to integrate both sides. Somebody different, tell me how this integrates.
Y.
And then somebody tell me what's the process we're going to have to use to integrate this.
Use those to do six.
Right, it's messy enough. There's a lot of chain rule in there. That's not something I can do quickly in my head, so it's probably got to be u substitution. So I'll do that with you this time. So u is probably the stuff under the square root. I need 1x dx. Oh, actually, I've got a really good challenge question for you guys to see if you can figure out what I did wrong here, but let's go ahead and finish rewriting this. U to the negative 1/2. All right, this is sometimes hard for students to understand at first, but mathematically this is not correct. You have to do the plus c. Even if I only integrated the left side so far and I haven't had time to finish integrating the right side, when I integrate this, I need a plus c. That's not correct without a plus c. Now, when you integrate both sides at once, you only need 1 plus c, but this doesn't make sense without the plus c. If you integrate either side, you better put a plus c, even if it's just temporary. Okay, and then this guy, we could raise the power by 1, so that would end up being u to the 1/2. Divide by the new power. Dividing by half is the same as multiplying by 2. And then personally, this would create a plus c also, but if I take this unknown number, subtract it from that unknown number, I just like to have the one unknown number on the right. That's how most math people do that. But and then, what is our last step always to be?
Because you
Oh, okay, yeah, I already did that.
oh,
But what's the last step in all of these separation questions? Solve for y equals. It's just that this one's already done for you. Alright, so again, we're just trying to lean on the repetition here so that we feel like it's getting a little bit easier each time. Okay, so here's 13. I know Harper knows the first step because she's given us the first step the last 2 questions. So somebody else tell me, how do I start off 13?
Spin y prime to dy.
Very good. Change y prime into dy dx. Okay, and then we need to separate the variables. This looks to be a little bit harder on this question, so I want you to try that part. You try to separate the variables on your page. Alright, so again, this one's just a little bit messier, but you could add all of this stuff to the right. Again, sometimes you just can't do it in one step. You gotta force yourself to take a couple steps. Add all this over. dy's up in the numerator on the right, so that tells me that the y stuff probably needs to move to the right. Divide both sides by y. We could divide both sides by x and multiply both sides by dx. Anything else you tried is probably not following order of operations correctly. Again, it's fine not to be able to do it in one step, but don't make it harder on yourself by trying to do too much in one step. In fact, even from here to here, it might be good to do one more step than I did. You don't want to change the question at the beginning and then have no chance of it being correct. Alright, and so we do that so that we can integrate. This side should be quick. This side, I could probably do this without u substitution, but if you feel more comfortable doing u substitution, at least you should know that you're on track. One half u squared. And completely optional here, but I don't know. I kind of like the y stuff to be on the left, so I'm going to just flip my equation. I'm not subtracting anything over. I'm just going to make this be my left side and this be my right side. Typically when we solve for y equals, it's on the left, so it's just a little more familiar there. Also, I'm going to just go ahead and move this plus c over here. Okay, so what comes next? Okay, exponentiate, because e to the log base e of some stuff just becomes some stuff. That's the only way you're going to get that y out of that natural log. Okay, this, I would like you to try to write what you think I'm going to say next about this. Do what you think I'm going to do to this step. Write it on your page so you can see if it's correct guess. Okay, so this is like undoing multiplying by the same base. If you have exponents that are being added, it's like you've got e to this times e to the c. The reason why you have to do that and make a habit out of that is e to the c can just be thought of as c. And they will do that to you on multiple choice. If you don't practice that, you're not going to know where that goes. And again, I don't know if c is positive or negative anyway, so that's why I can just drop the absolute value sign. C can switch signs if needed, but that is what we would aim for in that question. What was that, 13? Okay. Alright, so this is the last of the general forms. So all of these answers had C in them. We didn't have enough information to solve for C. So is there anything about 13 you want to ask about? Yeah.
Can you simplify that?
You could bring this 1/2 up and change this to a 1.
Oh.
Or you could bring the 2 down and make it a 1. Either way.
I was thinking like the square root of x to the ln x times c.
One more time.
The square root of x to ln x times c.
But this is not times 2, it's to the second power.
Yeah, so it'd be like ln x times ln x, which which would be like ln of x to the ln x, which then you take the square root because of 1/2 is the natural log of something, e to the power of that, so it becomes the square root of x to the power of ln x, and then times c.
You might be correct, but I'd have to see it written down for me to give you full confirmation here. Yeah.
I have the same kind of question. So if you move that 1/2 to the top, then it'd be natural log of x to the power of 1, which is just natural log of x.
Correct.
Could you then just make it so it's either the natural log of x just equals x?
Correct. You could.
Okay.
So that's simplifying. I wouldn't do that personally, but of course, if it was a multiple choice question and you got down to here and none of your answers look like that and you felt confident about what you did, then yeah, I would tweak it a little bit and try to simplify more. But just in general, it's kind of weird to just keep practicing the simplifying. But yes, I believe you'd be correct on that. I think you could simplify a bit more. Okay, let's look at 15. So again, we're just doing the odds. So 2, 3, I think we just got like 4 more of these to go. Again, we're trying to get you to be as comfortable with this question type as possible, even though it does take more practice than just this one full class period. But this is a little bit different because now they're giving us a initial condition. So we should not have C in our answer because we can actually solve for C. But you can still do the same first step. Change y prime into dy dx. You still have the first same major goal of separating your variables. You're still separating your variables to make both sides integrate nicely. Once in a while you're going to have to do u substitution, but this one they both did great. You always have to remember your plus c. But for this question type, it's going to add a step or two here because we should be able to figure out how big C is and not call it C anymore. Again, I just tend to solve for C the second that I see it. That's just what I think is the best. So if I plug in 0 for x, this goes to 2. And plug in 3 for y, this goes to 9/2. Subtract 2 from that. You see 2 is the same thing as 4/2. So 9/2 minus 4/2 would be 5/2. Wherever you started solving for C, plug it back in there. And then finally, like all questions, finish solving for y equals. So we can multiply everything by 2 and take the square root of both sides. Now, questions 1 through 13 that we looked at, I didn't have any way to check or feel any better or worse about my answer at the end. What can I do about this question to feel better about my answer? One more time. Okay, yeah, I guess you could take the derivative of this, but that would throw you, you would still have to solve this for the derivative to work that way.
Just plug your numbers back in.
Right. It has to go through that point. So if your answer doesn't go through that point, there's 0% chance it's correct. And again, a lot of times on multiple choice, you might be able to completely eliminate an answer or 2 or 3 because they just don't go through that point. But plugging in 0 for x, this becomes 1. Anything to the 0 power is 1. Times 4 is 4. Add 5 to that, you get 9. And the square root of 9 is 3. So it's not 100% guaranteed, but it's pretty likely. If you made a mistake, it would be a weird coincidence that it still goes through that point. Alright, so I know I did most of that for you, and we are running low on questions, so now I'm going to ask you to start giving these a shot before I go over them with you. So, go ahead and try all of number 17. If you get hard stuck, go ahead and move on and start 19 while you wait. And if you think you got it correct, check your answer in the back of the book. If you got it right, you can move on to 19 and you don't have to pay attention to us going over 17 when I go over it. I'm going to give 4 more minutes. So again, if you're completely stuck and you know you can't do anything else, move on. If you think you're done, check the answer in the back of the book and then move on. Okay, 2 more minutes and I'll go over it if you're having issues. I'm about to go over it. So again, it's fine if you're still having issues. Usually takes a little bit longer, but for it to go better, you got to kind of learn from your mistake. So just glancing at this one, I think probably the most challenging part of this one is kind of up front, separating the variables. So I don't know, you could either subtract this over or subtract this over, but you've got to do that so that you have a statement that looks like this. These two sides could be switched, of course, but then you could multiply both sides by dx and divide both sides by y. Again, your left and your right side could switch, but just kind of glancing at the question, that's probably the hardest part there. Yeah.
Wouldn't you do the x have to be negative because you would do 2 powers?
Oh, yes, I'm sorry. This would be negative, so leave the negative there. Thank you. Okay, now the integration should go pretty smoothly. This would be 1/2 x squared plus x equals negative natural log absolute value of y plus c. We've got enough information to actually solve for c, so we need to do that. If I plug in 1 for y, this goes to 0. The natural log of 1 is 0. That's come up several times today. Make sure you write that on the top of your paper if you don't remember that. When x is negative 2, so this would be 4 divided in 2 would be 2, minus 2 would be 0. Did y'all get 0 for C? Okay, so that's nice because it makes some of it just go away. Now, to finish solving this for y equals, I don't know, maybe this doesn't bother you, but I really just prefer for this to be on the left side. So I'm not adding or subtracting, I'm just swapping the sides. I think it's a little easier to see. Okay, you should not exponentiate yet. If you exponentiate here, this is not the property you think it is. There's not a log property that says e to the negative log base e. You need to get rid of this negative first. So multiply everything by a negative. Now it makes sense to exponentiate. E to the log base e of the absolute value of y would be the absolute value of y. Remember, you can't just pretend like it goes away. We're going to have to worry about that at some point. This we could split up and try to simplify a little bit, but I'm not sure that that's really going to do anything, so I'm just going to leave all of that as the exponent of e. Now, this is close to what I want, but our goal wasn't to solve for the absolute value of y. Our goal was to solve for y. So, if you go back to the notes that we did this morning, that simple algebra example, the absolute value of x equals 2, remember that the stuff under the absolute value might equal the other side, and it might equal the opposite of the other side. So, my answer might be this, and my answer might be this times a negative 1. The only way for you to know is you have to make sure it goes through this initial point. If that's a true statement, leave it alone, and if one side's the opposite, multiply it by a negative before you call it your answer. So if I plug in negative 2 for x, this becomes 4 divided by 2 would be 2 times a negative becomes negative 2. Subtract the negative 2 is like adding a 2. All of that becomes 0. Anything to the 0 power is 1. So all of this becomes 1, and y is 1. Since that checks out, I'm not multiplying it by a negative. But if the right side had been negative 1 and the left side had been positive 1, I would need to throw in a negative here as part of my answer. Now again, I think you could probably rewrite this a little bit too with exponent rules, but I don't really see any real benefit there, so I probably wouldn't even try to do that. Okay. Anything specific about 17 while it's still up? Okay, then for 19, I'd like you to go ahead and start this one by separating the variables, please. I'm going to just go ahead and switch this to dy over dx. I think we've talked about that enough. So go ahead and separate the variables. I'm going to freeze my screen and I will do that also, and I will go ahead and do the integration for you. So. Okay, so just the separating, you would have gotten to this. Again, your left side and your right side could be switched, as long as that's what you got. But the reason why I wanted to do the integration for you is notice that the left and the right are the exact same thing, except one is y's and one is x's. So if you do u substitution for one side, and you figure out how that one integrates, you can just copy that and use it for the other side also. Of course, we don't need 2 plus c's though, so I'm just going to have 1 plus c. So I just wanted to point that part out to you. That even though you did have to do u substitution, it was the exact same thing twice, so at least you got to use the information twice. Okay, so now you need to solve for C. Plug it in, and then try to solve for Y. So I'd like you to take a couple minutes to try to finish that. We will go over it, so that one will be finished, and unless you were able to work ahead, you'll have just 2 questions for homework, 21 and 23. I do have both of those worked out on the website too, so that way if you have any issues, you can watch the video to get your homework completed. Yeah.
Can you just do, like for, say the right side, you could do x times the natural log of 1 plus x squared, and then just account for
You were saying x times what?
Natural log of 1 plus x squared. And then you can just account for chain rule and you don't have to do substitution.
No, because the derivative of this, you'd have to do product rule. That only works with constants, where you can just throw the chain rule part out front. If I take the derivative of what you said, I would have to take the derivative of x times this left alone plus then x left alone times the derivative of this. And that's all of that's wildly different than what you needed. The multiplying by the undoing of the chain rule out front only works if it's a constant. If it's a variable, because of the way derivatives work in product rule, it's not what you intend it to be.
Teachers, pardon this brief interruption. This is a reminder. All seniors advisors, when the bell rings to dismiss for advisory today, all of y'all go to the PAC. It's a senior informational meeting. So all senior advisors, go to the PAC today during advisory. Thank you very much.
Okay, just quickly, I went ahead and started writing it out so that we could get it in here. But I plugged in 0 for x, started solving, or 0 for x, square root of 3 for y, started solving for c. I would say one thing you might not have done is done that. But if you bring that 1/2 up as an exponent, 4 to the 1/2 is like the square root of 4, which is just 2. So I made that change because it made my life easier. I plugged that back in for c. I multiplied everything by 2, exponentiated both sides so that that stuff went away. When I exponentiated this, e to the 2 natural log of 2, this 2 could come up as a 4. E to the natural log of 4 just becomes a 4, if you're curious where that came from. I checked the initial condition before I dropped the absolute value sign. I didn't need to multiply the other side by a negative. And then to finish, I undid a +1 with the -1 and undid a square with a square root. So, sorry, that one's a little bit rushed there, but again, this one and the last 2 questions that I want you to try before next Tuesday, if you have issues with those, if you're not getting what the back of the book has, I do have videos on my website, so at the very least you can watch those and have it complete. So you need to finish up those few questions. You might want to just write those questions down on your page so that you don't need a book. You might want to look up the answers in the back of the book and put them next to the questions so that you know without a book. But I need you to please finish that up and turn it into Google Classroom 101 before next Tuesday, please. And again, unless you just feel like you are way behind everybody else, again, you don't need to stress yet about not having this math. It takes more practice. The majority of my class, you'll still be practicing the same thing. So you don't need to stress about it yet unless you feel like you're really far behind.
Yeah, thank you.
DT is the derivative of DT. And DT is the derivative of DT. So basically like this, like DT is DT. Yeah, it's just a constant. Okay.
The answers for 21 and 23 on the website.
There's videos, so yeah. It'll have the explanation and the answer at the end. Have a nice weekend. Thank you.